Okay, in the last video, we talked about the objectives and for IoT architecture. So in this video, we talk about a widely accepted IoT architecture like this. The identifiers that are needed when building an IoT solution can now be put together in a larger context by proposing a single view of the main functionalities. So it looks like this. So if you are in information technology or computer majors, you may have seen this. But if you are not, that's totally okay. Basically, for this architecture, it follows the approach of looking at the system capabilities from a layered point of view as a functional domains that goes across the. So let's into the details of each layer. We have an overview. So there are seven separate because they are layers. So they have relationship basically at the very lower here. It is an asset layer. Basically, it refers to the lowest level. This layer, it is the most upper level. Basically, that's where the business is making decisions and carrying out. That will go across different layers to make sure that the architecture will work as we expect. Let's look at the different layers. So at the lowest, the asset layer, the layer is not providing any functionality within a solution. Basically, it represents the, real-world objects and entities system. So the assets of interest are the real-world objects and entities. They are subject to being monitored and controlled, as well as having to represent and identities. That's the asset layer. Asset layer can also be the virtual, they are more virtual character. And a little bit, it will be the device and resource layer that provides the main functional capabilities of sensing, actuation, and embedded identity realm and the physical world. So basically for the asset layer, it is the physical world. So device and resource layer will insert the physical instructions to be monitored and identified. So for this layer, it includes the sensors, the actuators, gateways. Gateways mean including the RFID devices, the QR code, also some other useful which provide traceability. You can think of the layer as a process of using the IoT concept. So for the S layer, we have the object or the physical items of interest, right? The machine, the people, and other things. And then we use device and resource layer, which include the sensors, actuators, and those RFID devices, and kind of control the physical machines. But as we go on, after we collect data from the assets or unload the data, and after we collect data from then most of the time we want to upload the data to the upper level for processing. In that case, we need the communication layer to provide the means of connectivity between the devices and resources. But basically, you can include the local area network and the wide area. So these two terms look professional, but when I point out what they are, you immediately. So wide area network can be realized by different wide technologies. For example, the fiber, you have Google, the digital line, basically that's the cable you plug in to the wall to get internet, right? And also for the wavelengths, they all belong to the wide area network. So the W stands for wide, WID. So if you look at this, the DSL, the net satellite, they can enable the communication of different devices within one line. For example, using satellites, you can communicate with people on the other end of the Earth. And for the cellular mobile network, basically it will cover also several miles, right? Considered to be wide. Being said, so we have the local area local area network. So, prime examples, we have the finance personal area network, which is used for healthcare applications, home and building area network, which are for automation control applications, and neighborhood area network, which are for smart electricity grid. Yeah, these terms may still look quite new to you, but if we put it into the, we see that for the wired LANs, we have the Ethernet, right? Communication, which you may not see it, but it's very common in something like that. If it comes to wireless, then we have the including the IEEE, basically stands for different protocols. I guess I may have some typo here. So one of them should be Wi-Fi. Okay, and we also have the Bluetooth for this local area network. So for the Ethernet, for the Wi-Fi, for Bluetooth, you know that they may be applicable, maybe in 30 feet, some range like that, but no farther. So that's why they're considered to be local area network. But sometimes there is no this clear boundary between LAN and WAN. Okay, now help of the communication layer, we that the data from the device, from the sensors, from the actuators can be transferred to the upper level. So we will come to the service layer. Basically, IoT applications benefit from simplification by relying on support services that perform common and routine tasks. You need to put them into some special organizations. We may want to tidy, clean up the data so that noises will be removed. So this is at the service enable layer. So these are usually executed in data centers or server farms inside organizations or in cloud environments. So basically, after the data is uploaded to for example, to the cloud, so they will do some initial common tasks. For example, they will mark down a timestamp for the data, mark down the originality, and also filter the data. For example, if you monitor the temperature of a room, so if there's no change in the room temperature, intermediate data will be removed to save the space. So for this layer, the service can provide uniform handling of the underlying devices and network, thus hiding the complexity in the corresponding layer. So this device management that can do remote software updates, do remote diagnosis and recovery and something like that, and machine learning algorithms, and also communication are also provided layer, including following the protocols and also the messaging queuing mechanisms for the protocols. For example, semantics or some syntax for the communication. Basically, for example, the body temperature is 37, no, 100. Okay, so the data need to be transferred into the database or within or using the communication methods. We need to add something before data after the 110. So these functions are provided in this layer automatically so that everything will be streamlined. So where the resource, communication, and service enablement layers have text, networks, and network nodes and computer servers, the data and information layer, more abstract set of functions, extract insights, capture knowledge, and provide advanced automation in different IoT applications. So key concepts here include data information models, presentation in general, and the focus is on representation and organization of information. So what mentions here is that for the research, we have the device and text, right? We have network and network nodes. Basically, for the previous several layers, the resources, the communication, the physical realization, the device and text are physical, the network and network nodes are physical, and service enablement layers, the computers. But for the data and information layer, which we are talking about, it's more abstract because it does not have a specific physical counterpart for this layer like before. So this layer focuses on the representation and organization of information. In other words, so any functions that can realize of information, it can be considered to be this layer. Remember that for the layers, they do not need to be physical items. They can be specific. And after the data and information are organized, the application layer in turn provides specific IoT applications. For example, you may want to know changes in the temperature or the weather. You may want to use an app to find out the nearest location of a restaurant. So that's what as part of the application layer. This is an open-ended array of different applications from various setups across the industry. So you have health monitoring apps, you have entertainment apps like YouTube. You also have social media apps, something like that. So they all belong to the application layer. On top of the application layer, we have the business layer, which focuses on supporting the core business or operations of any enterprise, organization, or individual choosing IoT application. So this is where the integration of the IoT applications into business processes and enterprise systems. So for some small IoT companies, actually they may or may not have this layer. So some of the companies, they only develop apps, right? And they just collect some of the apps, or you may need to supply some services. But if the company has a higher level, then a business layer often is needed. The business layer provides exposure of APIs for third parties to get access to data and information, and can be contain support for direct access to application by human. So basically, we mentioned that we need open APIs so that different apps or different companies, different entities can share information that's realized in business layer. So by this moment, we have finished talking about the 7 horizontal layers here. Basically, it follows the process how data is flowing from the physical world, cyber world, and to the business. And we also have three boundary layers here, namely the management, security, and IoT data and services. Let's look at them one by one. Enterprise deals with the management of various parts solution related to its operation, maintenance, administration, and provisioning throughout the life cycle of the system. So that's why we need it to cover all the layers, how management is done, right? And security, yeah, it's straightforward. It's about the protection of system, its information, or any other harm. It is required across all layers, providing communication security and information security, basically within every single layer and also between the layers. And the final cross-functional domain is the data and services. The data and services can be done in a very at different levels of abstraction and complexity. So we have the different data processing, such as the simpler include event filtering and simpler aggregation, averaging, something like that. There will be contextual data and spatial and temporal information. Spatial means related to the space, location. Temporal means related to the time. And also, we can also have more advanced processing. but these are included in the data and it's needed for all the layers. And data and service processing also include different types of sensing, vision, closed loops. So in general, data and service processing can be distributed all the way from the edge of sensor node to a centralized data center, all based on the needs of it. Basically, for the for the IoT applications, it is data intensive, right? So whenever we have data, we will need these functions mentioned here and also here.